Oskar, a mobile braille keyboard for smartphones. My name is Johannes Streckebetz. The slick touchscreens of smartphones offer no tangible orientation for blind and visually impaired people. Accessibility information and communication technology hardware is lacking. We empower ourselves and build our own accessible mobile communication hardware. With digital fabrication, open source blueprints, and collaborative design, we create open and sustainable access to a connected world. A braille keyboard can be very simple in design. Oskar consists of 8 switches and a microcontroller. The data transfer is done via USB cable or Bluetooth. We have 2 versions of Oskar available. You can put Oskar concertina with 8 physical braille writer keys on the back of the smartphone.
B, A, Komma, Baba, S, A, E, T, sagt, O, S, K, A, R, Punkt, Oskar. Ausgewählter Text Baba, sagt Oskar.
Oskar Zitter offers 2 additional space keys for the thumbs. We solve following problems. Voice control is often not possible when on the move. Braille note takers are expensive and can only be used with a pad. With Oskar, smartphone control is mobile, discreet, fast and accurate. The entry is not sensitive to noise and can be made while standing or walking. Oskar is an open source project. You can download the building instructions. We have made a study at the Technical University Vienna. Blind and visually impaired people type on the smartphone 4 times slower than sighted people. After 5 minutes of training, blind and visually impaired people are 4 times faster than touchscreen entry and 2 times more precise than touchscreen entry. We are Erich Schmidt from the Federal Institute for the Blind in Vienna, me, Johannes Streckebetz, and many open source developers on which the project is based. We are currently addressing the following challenges. The solution should be cheap, because there is a little pay for blind and visually impaired people. Pre-assembled devices are more expensive than do-it-yourself kits. The building instructions require a soldering iron. Hot soldering iron can cause burn blisters on the fingers, with which no braille dots can be felt. Therefore, we are now developing self-assembling kits for blind and visually impaired people together with the Federal Institute for Education of the Blind in Vienna. This will allow us to become more affordable and make digital production work accessible to more people. We are looking for partnerships for the development of inclusive digital production. We would like to encourage all interested parties to get in contact with us so that we can find solutions with the greatest possible impact. Thank you.